So in this Lathe 100 series, we're actually going to start going over some of the operations of the lathe. So this is kind of what you've all probably been waiting for, is the moment you get to start cutting some metal. We're going to begin by installing the 3-jaw self-centering chuck. Spin that on, get a couple of the Tommy bars here, and tighten it down. And I've got a couple of pieces that we're going to start working with. These are both 1-inch round 6061 T6 aluminum, 1.5 inches in length, and this one I believe I cut about 2.5 inches in length, just so that we can do some test cuts and some different things on them. One thing before we can mount these in the chuck though is you'll notice that there are some sharp edges on there and some burrs, and those can be quite dangerous, cut you easily. They can also damage your chuck a little bit. You can see this one's got a larger piece hanging off there. So what we want to do is we just want to take a file and just quickly just break those edges down. We can see that this is a fairly rough cut. One thing I wanted to also quickly mention, since we haven't talked about files, is this file I simply picked up at Home Depot or Lowe's. Just look for a single cut file, which means the lines are going in a single direction rather than a crosshatch. And that should be good enough for your first file. What you're going to be able to get at a home center is going to be fairly limited. I'll do a full video on files later. Okay, so this first operation we're going to do is I've got the 1.5 inch piece chucked in here, and we're going to face it, which is smoothing out this section. This will get this surface perfectly flat. If we do it correctly, it will also get it much smoother, and it's going to get it to where it's square and perpendicular to this surface. So this is a fairly basic operation. One thing we do want to do is we want to make sure that our tool will turn freely, that we're not going to hit the surface anywhere as we move in and out. I'm going to set 0 on my hand wheel, just so that I know how far I am on my Z-axis from the face of the workpiece. And then I'm just going to back it off a little bit. This cut we want to make in starting from close to the center and then moving outwards. We're going to start just by doing some pole cuts on this, because I know that there is a little bit of a cant to this piece, to where the outer edge is further out. So I don't want to start a really deep cut to begin. We are going to do very, very shallow cuts, say maybe 5 thousandths or 10 thousandths to begin with. And we are going to do it dry here at fairly low speed, just so that hopefully we can get a little bit better visual. Make sure your safety glasses are on. We've deburred the piece so it's smooth on its edges. The tool we're using is a straight face tool. So a tool similar to this one, where there's really no angle on this edge. It's flat. This is a right-hand turning tool. We've set it at a slight angle to the faceplate. This way we're not rubbing the length of the tool as we're trying to cut. So we just need a slight angle. We'll get into more details on angles and approaches on cuts in a more detailed video. You can back off the Z-axis a little bit, just for safety. Turn on the lathe at a fairly low speed. We're going to set our Z-axis for 10 thousandths, so 0.010. And we're going to start slowly moving the face of the cutter across, slowly moving the cutter across the face of the work. We may not get much of a cut or any at all on this first path, because we are being extra careful here. We're going extra slow. We're wanting to take our time and not make any mistakes. So we are getting a little bit of cutting there on the edge. As you can see, not very much at all. I'm going to move the Z-axis back away and come closer to my center point again. And then we're going to move the Z-axis back in. Again, very, very light, since we're just learning how the machine feels and how to do these cuts. So this is another 5/1000ths in. We'll probably get a little more contact on the edge. That knocking sound we heard before means we have an interrupted cut, so we're not cutting all the way around the piece yet. We have to be extra careful on interrupted cuts because they can damage the cutter and they can cause some other issues. So I've backed the Z-axis off again, and you can start to see where we've got a smoother section depending on how the light picks that up versus the rougher section. Just on that one little segment, but we'll keep going and doing the same thing. So here you can see we're getting a better cut. Still interrupted. We're getting nice shavings. One of the things that we want to see here are more curlicue shapes. That's a good indication that the speed of our spindle and the feed rate of our cut across the face are looking good. So back off the Z-axis, just a small amount. We're going to come back close to the center again and put in, we're going to go for a 10/1000ths of a cut this time. Now that noise you hear is chatter, and I did bog the motor down a little bit. I have it on its high-speed setting, but as far as the pulleys go, but it's on a very low turning speed right now. So I'm going to go ahead and increase that a little bit. With the chatter, lubrication and changing the sharpness of the tool, as well as your speed and feed rates will affect some of the chatter and dragging noise there. So let's go ahead and increase the speed a little bit. Again, back off the Z-axis so we're not cutting as we're moving in. So that was much better. We didn't bog down the motor that time. For future videos, I'll probably switch to the slow speed just so that you can see the action a little bit closer. Don't reach in and try to grab any shavings when the motor's running. Definitely do that with the motor off. Or if you wish, use a pair of tongs or something along those lines to reach in there and grab it out of the way. Now our tool height is centered pretty well. There is a small nub there. That nub may be that I haven't moved all the way in. If your tool height is too low, you're going to get a point, or a small bar actually is coming out from the middle. That indicates that your tool height is a little bit too low. Depending on how precise you want to be here, that's quite easily knocked off with a file if you don't get it exact on, particularly for roughing operations. You can see we've got a fairly decent finish there, right? We can definitely look at improving our speeds and feeds and doing a shallower depth of cut to get a little bit nicer face on that if we wanted to. So I've again backed the Z-axis off. So we're not touching the face of the workpiece. Now I'm going to come back in and I'm going to set just a 5/1000. In this case, I'm going to move in that direction. So towards the center, and I want to get rid of that little nub. Now we'll cut back. This stuff, the aluminum is fairly soft, so handling it, you're not going to have to worry about it cutting you too badly. If you're dealing with harder materials like steel, these little edges can be like razors, so be careful with them. So I think that's good enough. We do have a good center height on the tool. There's no nub there. Now I'm going to loosen the tool post, and we're going to get ready to do our next type of cut. In this case, what I want to do is have the post roughly square and perpendicular to the workpiece. We're going to start doing a turning operation, which will cut along this face and reduce the diameter. One thing I do want to mention is that when we were cutting this face, our depth of cut is our depth of cut. As we start to cut in this way, whatever we set for a depth of cut, we're going to end up reducing the diameter of this by double that amount, because we're taking that thickness, that depth off of both sides, both this side and this side as the piece spins. So make sure that you do pay attention to that as you're working, so you don't turn your piece down smaller than you want it to be. One other thing is you definitely do want, let's say if you were making a 1-inch flywheel, for example, you wouldn't want to start with a 1-inch rod. At least not in most cases, because then you're going to have to reduce the diameter of it, and it's going to be 7/8 of an inch or so. So always start with a slightly oversized stock. Now in the reverse direction of that, from the opposite perspective, you don't want to start with a 1-inch diameter rod to try to get a 1/4 inch rod out of it. Now maybe you're doing a 1/2 inch or 3/4 inch piece with a 1/4 inch spigot on it. Then obviously you're going to have to turn that down. But otherwise you're going to spend a lot of time turning and reducing this diameter, and it's just going to waste not only material, but more, it's going to waste your time, quite a bit of time reducing that diameter. Now, I mentioned that we want this square. Again, we'll talk about some differences in getting different quality of cuts and different lead angles and things like that later on. But for now, we want the majority of our force on the workpiece to be going in this direction. We don't want the force to be going in a diagonal direction or a cross direction, because then we can push the workpiece out or deflect it, particularly if it was longer. So we're just going to do a straight cut to where all the pressure is going longitudinally along the piece. All the pressure is going along the z-axis. And that's what we want just for safety in these first videos. If you're doing roughing cuts and some other things we'll talk about later, or harder materials, you definitely want to change those angles. So we're going to start by just bringing the tool tip up to the piece, and we want to rotate the piece as we do this until we just start to come in contact with it. We'll set our 0. Again, make sure you rotate that piece in case it is out of round or chucked a little odd. Then we're going to back it off. This time we're going to be doing our feed in the z-axis. So we're going to move our x-axis forward. We're going to do a very, very light cut again to start, since we are just practicing, getting a feel for the machine, getting a feel for the motor, and we don't want to be doing super heavy cuts yet. You can get to the point where you're doing 50,000ths cuts, particularly on aluminum or softer materials. They have videos on their website where they're doing 50,000ths cuts even in hard material like titanium and some stainless steels. So The machine is capable of it, but just for safety and comfort level, we're going to start with very, very shallow cuts. I've set up for a roughly 5/1000 right here. So we're just going to bring the tool in and run it across. So we're not getting very much of a cut at all right now, but this is just a check of concentricity, so the roundness of the piece. One other thing I do want to mention is you want to make sure and stay well clear of the jaws of the chuck or collet or what have you. So you don't want to turn to the point where you're going to impact your tool into this spinning face. It'll be very bad because those are hardened jaws and it's a hardened tool, and there are 3 jaws there for an interrupted cut. So just be very careful about that. So we're going to back our tool off roughly 10/1000. Move it down. Now we're going to come back in 10/1000. So at this point we wouldn't take much or any of a cut if we went across the surface. We're going to move in another 5/1000 and see if we can start getting a cut. So you can see we're starting to get a little bit of a cut there. And as we progress down, I mean, our rod is definitely not running 100% true. That's to be expected. So we're going to back off 10/1000 again in our instance. Move down to the end. We're going to come in 10/1000 to be equal with the face, and we're going to come in another 5/1000. Getting very, very light cuts. The light cuts you'll also want to do as your finished cuts, possibly even lighter than what we're doing here. But for roughing cuts where you're just trying to get a piece down to size, you can certainly do heavier cuts. So this time we're going to do 10/1000, so 0.010. A little bit of a heavier cut. So this time we're going to do 0.015 or 15/1000. So just as we're getting comfortable with the machine, we're going to do some heavier cuts here. Still, this is a very light cut even for this machine, but so you can see how this will take some time to reduce the diameter if you continue to do very light cuts. Take another pass here. So this time we'll do a cut of 0.025, which happens to be exactly half a turn of the hand wheel on the Shoreline. Since that last cut was 25 thousandths, we're going to go ahead and take a shallower cut now. Again, just 5 thousandths. I've also increased the spindle speed a little bit. So you can already see the difference in the cut there, the smoothness of it. Not sure if the camera will pick it up or not, but even visually without it running, there's a definite improvement already. Now if we stop or if we move too slow, you'll occasionally hear a little bit of noise. That is again chatter that we're inducing. So I've turned off the lathe after that last cut. You can see why you definitely want to be wearing safety glasses. These things are going to come up and fly everywhere. Chips and kind of reading the swarf, if you will. You definitely want more pieces that are these kind of curling strands rather than these little flecks and just small pieces. As you change feed speeds, and if you're not perfectly smooth on your feed speed, you are going to get some variances here. But these tight curling chips are really what you want. Now, as you can also probably see, you do start to run into problems with items wrapping around the spindle. That will affect your quality as well if you're not clearing those frequently enough. It can be a little bit difficult when trying to balance applying lubricant and turning the feed wheels and clearing those chips out of the way, but it is definitely something you should attempt to do. This is a decently smooth finish for turning, and you can see that we've taken quite a bit off so far, even doing some very, very light cuts. Just continue to do those light cuts and varying the depth of cut and varying the feed speed and varying the spindle speed that it's rotating at, and stop and take a look at your work and see how it's looking. Properly done, you can get this to where it's an extremely, extremely high polish and smooth finish. This is still pretty rough. We're not using any coolant, which will definitely apply, and we're not doing some optimal feed rates for fine finish, but this is pretty good for some of our first cuts. So we've covered two operations so far. First one was facing, so flattening out this edge, and we've done turning, which is running along this length. Next, we're going to do something a little different, and we're going to do a drilling operation. Okay, for our drilling operation, I've moved our tool and our cross slide out of the way here a little bit. We may have to move it a little bit further depending on how everything works out here. We've moved our tailstock in, at least to the frame for now. And we're going to use the drill chuck. This is the 3/8 inch chuck, and we have a number 0 Morse taper on it to fit into the ram here. This is just a friction fit. It doesn't get screwed in or anything on this end. One comment about setting inserting a drill into the chuck, I'll use a little bit longer drill here, is you don't want to set the drill all the way to the bottom of the chuck, even if the flutes didn't start until further out here. The reason for this is the way these chucks work is they pull a bit down, and if you start with it all the way bottomed out and you pull it down, you can't actually lock the chuck. So make sure that you back it off a little bit. In the case of this type of drill, we're usually going to want to try to get it as close to the flutes as possible. And we're going to start with a center drill. So the same rules apply. Tighten it up fairly close to the flutes. And then use the included key to tighten it up. If you're worried about it slipping, you can actually go to all 3 holes, and that will give it a little bit tighter fit in holding that on there. You want to make sure that your ram isn't all the way in when you insert this. Main reason for that being that if the ram is too far in, it will actually end up ejecting the chuck. So that's how you remove items from the tailstock. We're going to move our drill bit up close there. And then we're going to tighten this screw that's nearly out of frame to keep the tailstock from sliding. We don't want this screw tightened because we do need to be able to move this forward. Make sure your safety glasses are on. So I'm going to give a quick plug on a book here before we get started on this. This is the Machinery's Handbook. This is an older version, the 23rd edition. It's a very thick book, as you can see. This particular printing, it looks like the 23rd edition was first printed in 1988. At that point, this book had been being printed for 75 years already. There are several newer editions now. This is a really good book to pick up if you need to, for reference tables and even for learning more details than definitely what I'm going into here. Why I bring this up now is talking about the speed and the feed that you'll want with these tools. There are reference charts to get you started in the Machinery's Handbook. Get an older version like that, pick it up used. You can get them for a fraction of the cost of a new one. The new ones are pretty pricey, and not a lot has changed in machining, particularly for the type of work a home shop machinist is going to do. So we're going to turn our unit on and begin feeding the tailstock. So I'm just going to put a few little drops, probably just 1 drop if I can manage it. On the cutter, I'm just going to use a sewing machine oil for now. It's not the best for this type of operation, but for drilling, particularly with these small drills, you do want some lubrication in there. Now, if we were to be doing this for a center, that hole would be too small. All that we've really done is gone the depth of this first piece of a bit. We need to get into this angled piece in the back in order to locate for a center, whether it be a live center or a dead center, or also even to locate a drill bit. We don't need to go all the way in. Make sure you back out and clear off chips frequently. Less important since we're doing a really shallow hole here with a center drill. But that's now ready to accept the center if we wanted to further support the work. The procedure is the same if using a longer drill bit. Again, use a little bit of lubrication on a longer bit. Definitely back it out more frequently to clear the chips, and you'll get a nice smooth hole. So I'm just going to, I've loosened the tailstock so we can move it back and forth just so we get clearance. And we're going to go ahead and eject that arbor. So now we're going to show a variation on work holding, this being using a center in the tailstock. So we have a dead center here and a live center. The difference being that this has bearings in it, this does not. If you use this, you're going to have to keep that point lubricated, because otherwise the friction of that spinning piece on this part that isn't going to spin is going to be fairly significant. So you want to keep that lubricated very well. The better option in almost all situations is going to just to use a live center, which we're going to do here. And lock down our tailstock. Now we're going to extend out the ram until we come in contact with the piece enough that it's going to spin the bearings in the center as well. Now at this point we do want to lock the ram. So by locking the ram, this isn't going to back out due to any pressure, and it's going to stay and continue to hold the workpiece. Now this is a really short workpiece, so we really didn't need to support it in this way unless we're planning on doing some very heavy cuts. But I just did want to demonstrate how to use a center. You definitely need to use this for longer pieces because the amount of support you get off of just the jaw and this small gripping area on a longer piece is not very significant.